Welcome back to the channel. In this video, I will be discussing the most essential topic known as TCP IP protocol suite, which is also known as TCP IP protocol stack. It is the most commonly used protocol suite, so let's dive into it. But before that, don't forget to like and subscribe the channel for more tech related content. Let's have a look at some of the agenda items of this video. Now we are moving on to understand what is TCP IP protocol suite. TCP IP protocol suite is a set of protocols to allow the software and hardware to perform function. The idea of this protocol suite was presented by the Department of Defense and ARPANET project in 1969. You can also say that it is the foundation of Internet. If you have fully understood the OSI model, then it is like you have learned 70% about the TCP IP protocol suite, as the focus of OSI model is upon layers, while TCP IP is all about protocol. According to the given textbook, the TCP IP protocol suite can be explained based on three major points, such as TCP IP architecture, TCP IP ports, and TCP IP application. So let's first discuss what is TCP IP architecture. The TCP IP architecture can be divided into four different layers, such as application layer, transport layer, internet layer, and network access layer. So let's start from the application layer. This is the layer where users interact directly by using different services. The application layer of TCP IP protocol suite is responsible for creating a bridge or interface between the user and network. The top protocols operating at this layer are HTTP, FTP, SMTP, DNS, RIP, SNMP, and so on. This layer enables us to perform directory services, emailing, browsing, file downloading, and resource sharing. These applications use the services provided by the lowest layer to send and receive data. There is a huge list of protocols operating at this layer. We have highlighted some of the important protocols based on primary functions and common uses in this table. So press the pause button and take some time to read this frame. Transport layer is the second layer in TCP IP protocol suite. This layer ensures reliable or fast delivery of data. The top protocols operating at this layer are TCP, which is Transmission Control Protocol, UDP, User Datagram Protocol, and SCTP, Stream Control Transmission Protocol. This layer, with the help of Transmission Control Protocol, makes sure your communication is reliable. It is like sending a registered letter. It checks if all the packets are out safely and in the correct order. If any are missing, it asks for them to be resent. It also manages the flow of data so one side does not overwhelm the other. The segmentation and reassembly is also the major function provided by the transport layer. It also uses UDP for the fast and connectionless transmission. The summary of comparison of both protocols such as TCP UDP is given in this table. The third layer of TCP/IP protocol suite is called Internet layer. It handles the routing and addressing between the networks. The top protocols operating at this layer are IP, ICMP, ARP, IGMP, and RARP. This layer is like a postal service of the Internet. The IP is responsible for giving every device on the Internet a unique address, like your home address, for routing your data to the correct destination. It breaks down your information into smaller pieces, which are called packets, and figures out the best path for them to travel. The list of different protocols operating at the Internet layer, along with features and use cases, are given in this table. The final layer of TCP IP protocol suite is called Network Access Layer. It physically sends data over the network medium. The top protocols operating at this layer are Ethernet, Wi-Fi, ATM, and frame relay. This is the foundation as they deal with the physical connection to the network, whether it is through the cable, Wi-Fi, or your mobile data. It is like the actual road your messages travel on. The list of different protocols operating at the network access layer, along with features and use cases, are given in this table. The architecture of TCP IP protocol suite based on different layers have been discussed. So let's quickly recap the individual function of each layer while moving from top to bottom. The application layer allows users to use different software for emailing, file sharing, downloading, and some other activities. Then comes the transport layer that ensures the reliable and fast delivery of data and flow control of data. The transport layer passes the control to the Internet layer, which is responsible for forwarding packets across the different networks by using IP address. And finally comes the network access layer, which is responsible for sending data over the cables or wires. Another component of TCP IP protocol stack is the TCP IP ports. TCP IP ports are the virtual endpoints for sending and receiving data between devices on a network. They are used in combination with IP addresses to ensure the data reaches the correct application or service on the device. Think of all IP address as a house and the port number as the door number. There are two categories of ports for sending and receiving data on computer, such as TCP and UDP. The total number of TCP ports are 65,535 and similarly UDP are 65,535. The ports are assigned by IANA, which stands for Internet Assigned Number Authority. The port numbers can be divided into three different ranges. The first one is called well-known ports. These ports are from 0 to 1023 and normally used for sending emails or web packets. The second category is called registered ports. These ports are used by specific applications that are not the part of the Internet Protocol, such as well-known ports, but they are still recognized and assigned for organized use. These ports are officially registered with IANA, which is Internet Assigned Number Authority, for use by user application and software vendors. These ports ranges from 1024 to 49,151, normally used by Skype, BitTorrent, MySQL, and so on. The last range of ports is called dynamic or private ports. These ports are also called ephemeral ports, which are temporary port number assigned by a computer's operating system when it initiates a connection to another device. These ports are not permanently assigned to any service. They are used for short-lived communication. These ports ranges from 49,151 to 35,535. The last component of TCP/IP protocol suite is the TCP/IP application. We are going to explore how everyday applications use the TCP/IP protocol suite or stack. Let's begin with the most familiar tool, which are browsers. Web browser like Chrome, Firefox, and it allow us to access websites using protocol like HTTP and HTTPS. When you type a URL, the browser uses TCP/IP to request that web page from a web server. It also uses a DNS to translate the website name into an IP address, just like looking up someone's phone number in the digital phone book. Another application of TCP/IP is web server. On the other side, we have web server, the most powerful system to listen for the incoming HTTP requests and respond by sending HTML, CSS, images, and video back to the browser. Behind the scenes, it is all made possible through the TCP/IP communication. The third application of TCP/IP protocol suite is file server. Moving on to the file server, these are used in offices, schools, and network to store and manage files centrally. When you upload or download a file using FTP, SFTP, or Windows chat folder, you are actually using TCP/IP protocols like FTP or SMB to transfer data securely between computers. Another application of TCP/IP is in terminal server. Next are terminal server, which allows remote access to the desktop or server. When you use remote desktop protocol RDP or SSH, TCP/IP again at work, creating a secure and reliable connection between your computer and remote system even across the globe. Another application of TCP/IP protocol suite comes in online games. Games like PUBG, Fortnite rely heavily on UDP from the TCP/IP suite. Why? Because UDP is fast and doesn't wait for the acknowledgement, ideal for the real-time action like shooting, jumping, or driving. Meanwhile, for the things like logging in or chatting, games use TCP to ensure reliability. And finally, have you ever seen your system restart for update? That is window update using HTTPS or BATS, a smart background transfer system. It downloads updates using TCP/IP in a way that doesn't overload your internet. That ends up our discussion. So if you have any question, then drop in the comment section. I will try my level best to respond to your question. Thanks for watching and have a good day.